All right, guys, this is today's lesson on volume. We're going to mix it up a bit. We're going to be talking about frustums. That's right, frustums, the shape you've never heard of. What is a frustum? Well, look at this. Can you kind of tell? It looks like a lampshade or like a cup, kind of. A lot of cups are frustum shape or made of multiple frustums depending on the cup. But all a frustum really is, when you boil down to it, is a cone with a cone cut off. Or it could be a pyramid with a pyramid cut off. So if I just type in frustum, you can see some more examples here. Boop, let's take a look. What is a frustum? What does it look like? It could be a pyramid frustum. It could be a conic frustum. Here's a pretty good example of what it kind of looks like. Here's a frustum of a cone. It's a cone with a cone cut off. And kind of the same idea with a pyramid. And the part that's left over is called the frustum of the cone, or the frustum of the pyramid. So, what do we do? How do we solve these? Well, good news is you're going to do pretty similar work every single time. All right, so let's take a look. So, what if this kept extending? There's a cone that used to kind of exist. If you extend these two sides, it would meet somewhere up there. And what we're going to do is find the volume of the original big cone, the volume of the smaller cone that's been chopped off, and we're going to subtract the two. That's going to be our plan. This is what I want from you every time you do one of these questions. I want you to draw a right triangle that represents the frustum. Basically, it's like a cross-section of the frustum. And if you were to spin this around in 3 dimensions, that's what would make the frustum. So this is what we're going to draw every time we work on a frustum. What do the different parts represent? Well, this represents the big radius at the bottom. This is the little radius here. This would represent the height, and this would represent the slant height. Up here, so this is the height of the frustum, and then this would represent the cone that's not actually there. So you need to keep that in mind. The frustum is really just this part, and a frustum has 2 radii, a height and a slant height. All right, so we're going to work on just the frustum. Sorry, we're going to work on just this triangle. It represents all the pieces. Big R is 33. Little r is 25. And the height over here, this 92, that's this vertical height. And we're going to get that in the correct spot right there. That's my 92. What we need is the height of the small cone, which would then help us get the overall height of everything. So this is actually the reason one of the big reasons we're doing this is this brings us back to the first semester. What does that work look like? This is a proportion. Now remember, we can go in between parallel lines all day long. But if we're going to use the actual parallel lines, like if we do x over 25, that's left over bottom of the small triangle. We have to do left over bottom of the big triangle. It has to equal x plus 92 divided by 33. So it is left over bottom for the small triangle equals left over bottom for the big triangle. Then we cross multiply. That's going to be 33x. When we distribute, we're going to get 25x plus 2300. So 8x equals 2300. So 2300 divided by 8, x equals 287.5. So this part way up here is 287.5. Now we can get the volume of the 2 cones, the original big cone and the cone that was cut off. So we're going to do the volume of the cones. The volume would be 1/3 pi times big radius times big height. Well, what is the big height? We're going to have to add those 2 numbers together. So plus that 92, and the entire distance is 379.5. So the original cone would be all that. Then we're going to do minus 1/3 pi little radius 25 squared times little height, which was 287.5. And this is the answer. That's the volume. You can go from this line straight to the final answer. I am not going to type the pi's into my calculator. When you type an irrational number into the calculator, you open up the door for problems. So because they're both in terms of pi, I'm going to type it in one line, but I'm going to leave the pi off. I'm going to do 1/3 times 33 squared times 379.5 minus 1/3 times 25 squared times 287.5. And I'm going to make that a fraction, and this is a wonky fraction, but it's 233,588 all over 3 pi. And that's the final answer here. Volume of the big cone minus the volume of the small cone. Okay, moving on. Here's another frustum. There are a lot of issues here compared to the one we just did. First, I gave you diameters instead of the radius. Big deal. I gave you a slant height instead of a height. Big deal. It's upside down, and they're decimals, not whole numbers. All of those things could be potential problems. But every frustum, I'm going to draw the same opening picture. I'm going to draw this situation. Make sure you get the correct numbers in the correct spot. Even though it's upside down, I still draw my triangle like this. That's just me. If you want to draw yours upside down, go for it. But I know that the big base is going to be 2.4. It's got to be the radius, right? The radius of the big base is 2.4. The small base, the radius of the small base is 1.6. And this 1.7, that is a slant height. So that's what they gave us. This requires a little bit more work than the one we just did. If you ever get this situation, I think the best way to solve it is to drop that height and make a right triangle over here. And what you have is this section is 1.6, which means this section would have to be 0.8 because we know they have to add up to 2.4. So I drop that height straight down, I cut off the wing, and now I can do Pythagorean theorem. And hopefully you recognize that this is a triple. So this is going to be 0.5. No, it's not. It's going to be 1.5. What triple is that? That is 8, 15, 17. That is what it's based off of. All right, so now once you have that piece, now it's just like the last question. You're going to put an X on the unknown height of the cone that was cut off. You're going to do a proportion. Left over bottom for the of the small cone is going to equal left X plus 1.5 over bottom 2.4, the entire bottom 2.4 of the big cone. Cross multiply and solve, that's going to be 2.4x equals 1.6x plus 2.4. So remember you have to distribute. That's going to be 0.8x equals 2.4, so x equals 3. So this spot is 3. So now we just plug it in. The volume equals 1/3 pi big radius squared times big height. I don't see a 4.5 in there. Where's the 4.5? Where's the 4.5? The height of the entire original cone is 4.5. That's where it comes from. Minus 1/3 pi times little radius squared times little height 3. From here, you can just type this in. I don't expect you to be able to do all that work without a calculator. 1/3 times 2.4 squared times 4.5 minus 1/3 times 1.6 squared times 3. And I get 6.08. Don't forget your pi. Or if you write that as a fraction, that'd be 152 over 25 pi. I would actually take either one of those. Remember I say leave answers exact unless you're told otherwise? Is this an exact answer? That's my question. The answer is yes. I didn't round. That is exactly what this equals. If you type in 152 divided by 25, it is exactly 6.08. Kind of like 1/4 is exactly 0.25. These are the exact same value. There's no rounding there. So the rules are don't round unless you're told to. So these are both fine because neither one of these involve rounding. I would take either one, just so you know. All right, we're going to do some graphing questions here. It says, let's make it a little thicker here. Find the volume, all these graphs. Y equals 0, hoi vux, hoi horizontal, y equals 0. Remember, hoi vux, horizontal, y equals, vertical is x equals. You can remember that. Negative 1/4 x plus 7. There's my plus 7. We're going to go down 1 over 4. We're going to go down 1 over 4. Oops. 1, 2, 3, 4. Something like that. And then domain of 0 to 8. That's like saying x equals 0 and x equals 8. Domain is x. So from x equals 0 until x equals 8. Hoi vux, vux, vertical, x is vertical. I'm going to cut that out and just draw the part that we care about, which would look like this. We're going across the y-axis. They tell us here. So we're going to go negative 8, 5, 1, 2, 3, 4, 5. And we're going to draw the reflection on the other side of the y-axis. Can you get a sense of what this is going to look like? We're spinning around the y-axis. We're spinning around the y-axis. And it looks like a cylinder with a cone. I'm going to erase all those solid lines. It's a cylinder with a cone on top. It looks to me like a circus tent kind of. But we know that the radius is 8. The height of the cylinder would be 5. And then the height of the cone would be 2. So we have a radius of 8. Height of the cylinder is 5. The height of the cone is 2. So what's my plan? We're going to do the volume of the cylinder plus the volume of the cone. It's just cone plus cylinder here, guys. So that's going to be pi times the radius squared times the height for the cylinder plus pi times the radius squared times the height for the cone. Don't forget to divide by 3 for a cone. That's going to be 40, that would be 320 pi. How would I do that real quick? Well, I do 64 times 10 divided by 2. Isn't that the same as 64 times 5? Well, 64 times 10 is 640. Divided by 2 is 320. Over here, 64 times 2, that'd be 128 over 3 pi. Get a common denominator. This would be 960 plus 128, which is 1088 pi over 3. Being able to handle fractions like that's a pretty big deal if you want to be good at math and go to high levels of math, guys. You're going to do that a lot. Really starting in pre-cal, fractions will become very commonplace, and you just got to be able to handle them. All right, that's that entire problem. Do the next one. And I would love if you try to do them before I do them. I would love that. But this is y equals 3 halves x. That's up 3 over 2. Up 3 over 2. Up 3 over 2. And looking ahead, it goes from x equals 6 and y equals 0. So I know that it's going to be here. I know it's going to be at x equals 6 and at y equals 0. And this is going again over the y-axis. So I'm going to go negative 6, 9. I'm going to draw the reflection on the other side of the y-axis. And we're going to spin around the y-axis, make circular motions, connect opposite vertices with a circular motion. When you erase these solid lines, they would not be visible, but I'll put some dotted lines so we can understand, hey, there's something going on here. So it looks something like that. And what we have is a cylinder-shaped hole. Sorry, we have a cone-shaped hole in a cylinder. So we're going to do the volume of the cylinder minus the volume of the cone. So let's get our numbers. And hopefully you can see these numbers, but try to get them. Here we have the radius is 6, and the height is 9. And that's for both shapes. They both have the same radius and the same height. Okay. So the volume would be pi times the radius squared times the height minus 1/3 pi times the radius squared times the height. That's going to be 936, 360. That'd be 324 pi. And that's going to be 1/3 of that. So that'd be 108 pi. So that's going to be 216 pi. All right, that's that entire problem. That's done. Moving on. Find the volume of the resulting solid by rotating the region bounded by y equals 0 and that graph from 0 to 8. That's a domain again, so it's like saying x equals 0 and x equals 8. All right, so negative, let's start with, well, let's do y equals 0. It's from 0 to 8, so I'm going to stop at 8. And it's negative 1/4 x plus 7. So down, well, we already did this. So this is the same one that we had just a couple of questions ago. The difference is where are we rotating it? We're rotating it across the x-axis. So I'm going to draw the reflection across the x-axis. It goes to negative 7 and right there. Perfect. Now I know you're going to struggle. Mine looks awesome. Hopefully yours does too. And we're spinning this. So can you imagine spinning this in 3 dimensions? So we're spinning it around the y-axis. And when we do that, we get a circular base on top and bottom. Well, really, I guess it's the left and the right side. I'm going to erase that line, erase those lines, really erase those lines. So that's what our shape would look like. That's a frustum. It's on its side, but that's a frustum. So what is the radius here? That would be 7. What is the radius here? Remember, it started at 8, and that would be 5. That's kind of hard to see. And then what is the height? What is the distance between those two things? That is 8. So we have big radius of 7, little radius of 5, and the height is 8. It is, in fact, a frustum. So what do? We draw a right triangle. We put big radius in the correct spot, little radius, the height, and we need to find this number, x. So we set up a proportion. X over 5 would equal x plus 8 over 7. So that would be 7x equals 5x plus 40. So 2x equals 40 and x equals 20. Okay, so I've got x. Now I'm going to do, so x would be this spot, so this is 20. So we're going to do the volume now. So the volume would be 1/3 pi, big radius squared, times the big height would be 28, minus 1/3 pi times the little radius squared, times the little height there. Again, irrational numbers, I wouldn't type them in, but if I type in the coefficient, I get 1/3 times 7 squared times 28 minus 1/3 times 5 squared times 20. Oops, I hit the wrong button. And then I get, so that comes out to 872 over 3. Don't forget your pi. Okay, that was another frustum. Nice. Moving on. We got a couple word problems and then we're going to be done with this lesson. A pool is in the shape of a cylinder. The pool is 6 feet deep. Oh, I should have said the pool is currently 6 feet deep, as in the water level is currently 6 feet. I worded that poorly. The circumference is 20 pi. This is the diameter times pi. So the diameter is 20, so the radius is 10. You need to know that quick every time. I put every toy I own in the pool and they sank to the bottom. The water level is now 6 feet 3 inches. What is the volume of the toys? So you've got this pool. It's a cylinder. The water level is currently 6 feet deep. So think about the pool. It currently has water that is 6 feet deep. You put the toys in and that water level rises 3 inches. So we really only care about that. We only care about the 3 inches. That's it. We don't care about how much water was already there. We don't care about the 6 foot 3 inches. We care about the displaced height, which is 3 inches, which is 1/4 of a foot. right? 3 inches divided by 12 is 1/4 of a foot. Guys, I've said this all year. I do not care about units until they matter. So I pay attention to them, I just don't care about them. But since, really, honestly, that's not good. I just don't. So your science teachers, even the math teachers, they're going to yell at you. And units are important. I just don't pay attention to them. Everything here is in feet except for that 3 inches, so I converted that to feet. So what we have is pi times the radius squared times the height we care about. That's how much height the toys caused the water to rise. And so that's going to be 25 pi, and that is in feet cubed, which is what they told us to do. Beautiful. All right, one more, maybe kind of a challenge question. It's kind of wordy. There's a lot going on. We have a cylinder that's 100 pi. So we have 100 pi worth of tea, delicious, gross tea. Ugh. Okay, I don't know if you guys like tea. My son goes to the boba place every now and then. He gets like this dragon fruity thing with little boba thingies, and he adds little squirts, and I don't get it. It's so gross, but he loves it. I just don't get tea. I don't understand tea. I don't drink tea. I don't like sweet tea. I don't like unsweet tea. I don't like flavored tea. No tea for me. Okay, that's besides the point. Okay, there's a pyramid that has a slant height of 3 and a square base with a perimeter of 4. Sometimes if you don't have a picture, you can go Google one, which I did earlier. That's not it. There we go. There's a good example of a pyramid. But on a test or quiz, you can't do this. So you do need to be able to visualize this. You won't always have the picture. You need to be able to understand what's going on. Here's the pyramid. And they told us that we have a slant height of 3. And I need you to understand the slant height is this number, but I need the height. I need this number. What connects the slant height to the height? Well, that is the apothem. It's that line right there. Quick sidebar. What if I gave you the lateral edge? This is what we did last week. What connects the lateral edge to the height? That's to the corner. That is a radius. So that's what we had last week. So sometimes you have to use the radius. Sometimes you have to use the apothem. Today is an apothem day because we are connecting it to the slant height. You have to know that difference. If the perimeter is 4, that means each side is 1. So if we draw our right triangle, the slant height is 3. The apothem would be half the side. That's only true for squares. If it was a triangle, it would be 1/3 the height. But we got to be very specific and very clear here. Now, if I had a calculator, obviously I could type it in, but how would I do this without a calculator? Well, I would actually multiply by 2. And then you would subtract 36 minus 1. This would be the square root of 35. But then I would put that over 2, right? If I multiplied by 2 to get there, I divide by 2 to go back home. So that is the height. So what is the volume of the pyramid? 1/3 pi, not pi, 1/3 times the area of the base. Well, 1 times 1 is 1 times the height, root 35 over 2. So that volume would be root 35 over 6. So here's what's going on. We have a cylinder with tea. We pour tea into the pyramid until the pyramid's totally full. And then there's a rectangular prism that's 5 by 2 by something. So the volume of a prism is length times width times height. Well, okay, so we start with 100 pi worth of tea. We pour out root 35 over 6. So that's how much we poured out, right? We filled the pyramid all the way up. That's how much the pyramid holds. Equals the length and the height are 5 and 2. And we're looking for the width. So that'd be 100 pi minus root 35 over 6. That's how much t is left, equals 10w. 5 times 2 is 10. So we divide that side by 10. And so if we do that, I'm going to type that in, we would get 100 pi minus root 35 over 6 all divided by 10, and that would be 31.317. It says round to the nearest thousandths, and that would be our answer right there. So that's what the width would have to be if it's going to hold all that tea perfectly with no overflow, no spilling. Whew! All right, that's the main stuff I wanted you to know. I'm going to go do... No, actually, I'm going to stop right there. So I will see you next time. Hopefully that helped.